For most of human history, we believed intelligence was a human thing. A few decades later, we extended it to chimpanzees, then dogs, then crows, then elephants. But for most of that time, we still believed one thing. Intelligence belongs to creatures like us, creatures with backbones, with faces that look like our own, with brains organized the way our brains are organized. We were wrong. In fact, we weren't even close. Right now, in the oceans of our own planet, there are creatures that are doing things no animal should be able to do. There is a creature that can change its skin into a perfect copy of any background in less than a single second. It paints with millions of living pixels, and it does this while being completely colorblind. There is an animal whose body has no skeleton, no central brain, and 8 separate minds, one in each arm. It can solve puzzles, recognize individual humans, unscrew jars from the inside. There is a creature smaller than your hand that can punch with the force of a bullet, see colors that don't exist in human vision, and detect wavelengths of light that almost nothing else on Earth can perceive. There is a predator that has hunted in our oceans for over 400 million years, older than dinosaurs, older than trees, and that can detect the heartbeat of another animal through kilometers of water. There is a family of animals that pass down hunting traditions across generations, that have names for each other, that mourn their dead for weeks, that, by every measurable definition, have culture. And we live our entire lives without ever really thinking about any of it. This video is my attempt to fix that. I've spent months researching this documentary because I wanted to make something different. Not the usual deadliest sea creatures list, not the same shark and orca content you see everywhere. I wanted to make a video about minds, 8 different ocean creatures, 8 different kinds of intelligence, 8 different answers to one of the deepest questions in nature. How does consciousness work in a body completely unlike ours? Some of these animals you've heard of, some you probably haven't. But every single one of them is doing something that, when I really studied it, made me genuinely stop and think about what intelligence even is. By the end of this video, I think you'll see the ocean the way I do now, not as a beautiful empty place, but as something far stranger. A vast, dark, ancient city, full of minds we are only beginning to understand. Before we start, a quick favor. This channel is something I work on alone. Every like, every subscribe, every comment genuinely matters and tells me people are actually watching. If you enjoy these long, deep dive ocean documentaries, hit subscribe and let me know in the comments along the way which animal surprises you the most. And here's the question I want you to think about as we go. If intelligence can evolve in 8 completely different forms in a single ocean, how many other kinds of intelligence might be out there in the universe? Keep that in the back of your mind as we go. All right. Grab a coffee, get comfortable. Welcome to the deep mind. Let's go meet them. I want to start this documentary with something I genuinely cannot get over. There's a video I've watched probably 10 times, maybe more. It's just a glass jar, sealed shut with a screw-on lid, sitting at the bottom of a tank. Inside the jar is an octopus. Outside the jar, a scientist is watching. And here's what happens. The octopus presses one arm against the inside of the lid, then another arm. It starts moving the lid in slow circles, testing, adjusting, feeling, and then it unscrews the lid. From the inside, a creature with no hands, no tools, no prior experience with jars, no human teaching it what a screw top even is. And it figures the whole thing out from inside its own prison. I've shown this video to friends, to family. Watch their faces. They always have the same reaction. Wait, is that real? Yeah, it's real. And honestly, it's only the beginning of what this animal can do. If you watched my last documentary on ocean predators, you already know the octopus is brilliant. But this video is about something bigger than predators. This video is about intelligence. The kind of intelligence that shouldn't exist down there, in cold, dark water, in animals so different from us. They evolved on a completely separate branch of the tree of life over 600 million years ago. And the octopus is where we have to start. Because the octopus broke every rule scientists thought they knew about minds. Let me explain why. For most of human history, We believed intelligence required certain things: a spine, a central brain, a face, eyes that point forward, hands that grasp, lungs that breathe air. We thought intelligence was something that evolved once, in the line that led to mammals and birds and us. Then we started studying octopuses, and we realized something genuinely uncomfortable. The octopus has intelligence comparable to a dog, maybe even higher in some ways. It can solve puzzles. It can recognize individual humans. It can plan ahead. It can use tools. It can deceive other animals deliberately. And it does all of this with a body that has no skeleton, no face the way we understand faces, 9 separate brains instead of 1, blue blood, 3 hearts, and a body that can squeeze through holes the size of a coin. This is not an animal that's similar to us being smart. This is an entirely alien form of intelligence that evolved completely independently. Think about that for a second. It means intelligence isn't something special that only happened once on Earth. It happened at least twice, in completely different forms, with completely different blueprints. The octopus is, in a real scientific sense, the closest thing to alien life we've ever discovered. And it's been living right here in our oceans the whole time. Let me describe how its mind actually works, because this is where it gets really wild. You and I have one brain, centralized, in our heads. Every thought, every decision, every movement is processed through that one organ. The octopus has 9. One central brain in its head, yes, but it also has 8 smaller brains, 1 in each arm. And those 8 arm brains can think independently. They make their own decisions. They explore on their own. They solve their own little problems without checking in with the main brain. Imagine if your fingers could think. If your left hand could be solving one problem while your right hand worked on something completely different. If each of your limbs had its own consciousness, its own curiosity, its own opinions about what to do next. That's the octopus. When it explores a new object, like that jar with the screw top, its 8 arms aren't being commanded by central headquarters. They're running their own investigations in parallel. One arm is testing the lid. Another arm is feeling the texture of the glass. A third arm might be checking the water for vibrations. A fourth might be reaching out, exploring something completely different nearby. 8 separate streams of thought, all happening at once, in one body. I sometimes try to imagine what that must feel like, to be 8 minds in one skin, and I just can't. It's outside the range of what a human brain can simulate. We will never know what it's like to be an octopus. Not really. The experience is too different from anything we have. Now here's something I find absolutely beautiful. Every single sucker on an octopus's arm, and there are hundreds of them, can taste. Not just feel, taste. When the octopus is exploring that jar with its arms, it's not just feeling the surface, it's tasting it, reading the chemistry of the metal lid, sensing the residue of the human hand that closed it, detecting the salt levels of the water around it, building a complete chemical and tactile map of the world through touch alone. So when the octopus reaches into a dark crevice in the reef where it can't see anything, it's not blind. It's tasting the crevice, feeling for the chemical signature of a crab, sensing the texture of a hidden shell, reading the entire environment through its skin. The octopus experiences the world in a way we can't even imagine. Its body is its sensory organ. Every part of it sees, in a sense. Every part of it knows what's happening around it. I find that genuinely moving. There's something poetic about an animal whose entire body is connected to the world in such an intimate way. Okay. Let me share something with you that absolutely broke my brain when I first learned about it. In a few rare cases, scientists have observed octopuses doing something extraordinary. They collect coconut shells. Wild octopuses in Indonesia have been filmed gathering coconut shell halves discarded by humans, picking them up, carrying them across the seafloor with their arms, and stacking them carefully. They drag these shells with them as they travel. Why? Because later, Sometimes hours later, they assemble those shells into a portable shelter. They tuck themselves inside, pull the shells closed around them like armor, and hide. This is tool use, real tool use. The kind we thought only existed in primates and a few birds. But more than that, it's planning. The octopus carries the shells when it doesn't need them yet. It accepts the burden of dragging them around, knowing it might need shelter later. That's not instinct. Instinct doesn't say, future me will need this. That's foresight. That's imagination. That's a creature thinking about a moment in time that hasn't happened yet. I had to read about this twice when I first encountered it, because I couldn't quite believe an invertebrate was doing something I thought required a primate brain. But the octopus does it, casually, like it's nothing. I want to tell you something else that gets me every time I think about it. Octopuses recognize individual humans. There are documented cases, multiple, repeated, from different aquariums around the world, of octopuses developing preferences for specific human caretakers. They greet certain people. They ignore others. Some octopuses are known to spray water at staff members they don't like. Spray water at them, like a deliberate prank. They remember faces. They remember interactions. They form opinions about which humans they trust and which ones they don't. There's a researcher named Cy Montgomery who wrote an entire book about octopuses she befriended in an aquarium. She describes how one octopus would change color when she walked into the room, how they'd hold hands, well, hold arms, through the water, how the octopus would seem genuinely happy to see her. Reading her descriptions, you start to feel something uncomfortable. You start to feel like you're reading about another person, a very strange, very different person, but a person nonetheless. Let me show you how this intelligence works when the octopus is in real danger. Imagine an octopus on a reef. Suddenly, a shark appears in the distance. The octopus's first move? Not running, not panicking. It thinks. In a split second, it processes which direction the shark is coming from, how fast it's moving, where the nearest hiding spots are, which crevices are big enough for its beak, the water currents that might slow it down, and then it acts. But it doesn't just bolt. First, camouflage. Its skin changes color and texture in milliseconds, matching the rocks behind it. The shark, still distant, may not even see it. If that fails, second layer. The octopus launches itself backward using a jet of water from a special siphon in its body. Pure propulsion, fast and unexpected. And as it jets away, it releases ink. But here's the genius part. The ink doesn't just form a cloud, it forms a shape, roughly the size and outline of the octopus itself. A decoy, a fake version of itself suspended in the water. The shark strikes at the decoy. The real octopus has already disappeared into a crack in the rocks. This entire escape, strategy, execution, deception, happens in less than 3 seconds. It's not luck. It's not reflex. It's cognition operating at superhuman speed. There's something deeply beautiful about all of this when you really sit with it. The octopus has no shell, no armor, no teeth that can kill a shark, no size to intimidate anyone. It is physically one of the most vulnerable animals in the ocean. So how did it survive for hundreds of millions of years? By developing intelligence. Where other animals invested in armor or speed or strength, the octopus invested in thinking. Its evolutionary path is essentially this: I can't outfight you. I can't outrun you. So I'll outthink you. And it works. Spectacularly. It's almost philosophical, isn't it? Faced with a hostile world, the octopus didn't grow tougher. It grew smarter. It made vulnerability the foundation of its survival. There's a lesson in that. I think about it a lot. But here's the part that breaks my heart about octopuses. For all this intelligence, and all this curiosity, problem-solving, personality, they only live a few years. Most species, 1 to 2 years. Even the giants only reach 4. Then they die. And the way they die is one of the saddest things in nature. After a female octopus lays her eggs, she stops eating completely. She spends every single moment of her remaining life guarding her eggs, cleaning them, fanning fresh water across them, protecting them from predators. By the time the babies hatch, she's starving, exhausted, dying. She watches her babies drift away into the ocean, and then she's gone. Every female octopus dies this way. Every single one. It's not tragedy. It's how their biology works. They invest everything into one final act of motherhood. And it makes me wonder, what was she thinking in those last moments? What does an animal with that much intelligence experience, knowing, somehow, that this is the end? We will never know. The octopus carries that mystery with it. So, let's bring it back to that jar. The lid clicks shut. 8 arms begin to read the geometry of confinement. The octopus inside doesn't panic. It thinks. It tests. It tastes. It calculates. It probes. It adjusts. And eventually, slowly, deliberately, the lid begins to turn. In a few seconds, the impossible will happen. A sealed jar will open from the inside. A creature with no hands will defeat a system designed by a creature with hands. And as the octopus slips free, slides back into the water, and disappears into the darkness, somewhere in its 8-armed body, in its 9 separate brains, in those millions of taste-touch sensors covering its skin, something is happening that we still don't fully understand. Something is thinking. Something is aware. Something is alive in a way that has nothing to do with us, and everything to do with what intelligence on Earth actually is. The octopus opens this video because it forces us to confront something humbling. We are not the only minds on this planet, and the deepest, strangest, most alien intelligence we've ever encountered has been here the whole time, quietly opening jars in the dark. Okay, we need to talk about the cuttlefish. Because if the octopus broke the rules of what intelligence is, the cuttlefish broke the rules of what a body is. I've been studying this animal for months while making this video, reading papers, watching footage, talking to people who've spent their lives researching it. And I'm telling you right now, what I'm about to share with you is going to sound made up. It isn't. Every single thing I'm about to say is real, documented, filmed, tested in laboratories, published in scientific journals, and it's still hard to believe. Let me start with something simple. Imagine if your skin could change color. Not slowly, like a chameleon. I mean instantly, in less than a second. Imagine you could turn your arm green to match a leaf, or print stripes across your chest to mimic the shadows behind you, or flash a bright warning pattern across your entire body if someone scared you. That would be incredible, right? That alone would be one of the most impressive abilities in the animal kingdom. Now imagine that, but 1,000 times more advanced. Imagine your skin could change color and texture in real time, display moving patterns that flow across your body like animation, show different images on different sides of your body at the same time, mimic the exact texture, brightness, and contrast of any surface around you. Do all of this while being completely colorblind. That's the cuttlefish. And I haven't even gotten to the strange part yet. Let me describe how this actually works inside its skin, because once you understand the biology, you start to realize you're looking at something that genuinely shouldn't be possible. The cuttlefish's skin contains millions of tiny color cells called chromatophores. Each one is a sac of pigment surrounded by little muscles. When the muscles pull, the sac stretches out and the color becomes visible. When the muscles relax, the color disappears. And here's the thing. Each one of those chromatophores is controlled directly by the cuttlefish's brain, not through hormones, not through chemicals, through individual nerve connections. So the cuttlefish is essentially running a screen with millions of pixels, and it's controlling every single one of them with its mind. That's not a metaphor. That's how it actually works. Its body is, in every meaningful sense, a living display. a real-time, high-resolution screen powered by neural commands. The first time I really understood this, I had to put my laptop down and just sit there for a few minutes, because the implications are wild. Now, layer in the second system. Below the chromatophores are cells called iridophores. These don't have pigment at all. Instead, they bend and reflect light, creating shimmery blues, greens, silvers, almost like the inside of a seashell. Below those are leucophores, cells that scatter ambient light to match the brightness of whatever is around the cuttlefish. So we have three completely different layers of skin, each one manipulating light in a different way, all working together, all controlled simultaneously by one nervous system. Three independent display systems, stacked on top of each other, in a single layer of skin. I genuinely don't know how to describe this. There's nothing else like it on Earth. But here's where I have to pause and tell you the most absurd part of this entire story. The cuttlefish is colorblind. Read that again, slowly. This animal, capable of matching the color of any background in the ocean with incredible precision, cannot actually see color. Its eyes don't have the cells needed to perceive different hues. So how does it match colors it can't perceive? For decades, scientists couldn't answer this. It was a complete mystery. How can a colorblind animal generate accurate color displays? The current theory? The cuttlefish reads the world through brightness, polarization, and contrast, patterns we can't even detect with our eyes. It then translates this information into color displays that look perfect to other animals, even though the cuttlefish itself has no idea what those colors actually look like. Think about what that means. The cuttlefish is creating art for an audience it cannot see, in colors it cannot perceive, and getting it right every single time. That's not just survival. That's almost mystical. It's like a deaf musician composing a perfect symphony based purely on vibration. It's like a blind painter creating a masterpiece based purely on touch. It's like... I don't even have an analogy that captures it properly. It's just one of those facts about nature that makes you sit there in silence for a while. Now let's talk about what the cuttlefish can actually do with this living screen. The most basic ability is camouflage. Watch any underwater video of a cuttlefish settling onto the seafloor. In about half a second, it disappears. I mean disappears. Not blends in, not becomes hard to see, vanishes. Its skin matches the exact pattern of the sand, the texture, the brightness, the shadows, even the tiny imperfections. Within milliseconds, the cuttlefish has become indistinguishable from the seafloor, and then, when it decides to move, it just reappears, like a magic trick. But camouflage is honestly the simplest thing it can do. Here's where it gets really wild. When a cuttlefish is hunting, it can perform something called the passing cloud display. Picture this. The cuttlefish is approaching a fish or a crab, slowly, calmly, drifting just above the sea floor. And as it gets closer, waves of dark color start moving across its body, like clouds passing over a landscape. The patterns flow from head to tail in rhythmic pulses. To the prey, this looks like nothing threatening, just shifting light, like sunlight moving through water, like algae drifting overhead. The prey relaxes, doesn't run, and then, without warning, two long tentacles shoot out from beneath the cuttlefish's body, and the prey is gone before it understands what just happened. The cuttlefish hypnotized its meal. It used its own skin as a hypnotic device to literally distract its prey while it crept into striking range. I think about this sometimes. The level of strategy required, not just to catch a fish, but to use visual illusion as a hunting tool, to understand that what you display on your body affects how other animals behave. That's not just intelligence, that's an understanding of psychology. And speaking of understanding psychology, let me tell you about something cuttlefish do during mating season that genuinely blew my mind when I first learned about it. Male cuttlefish compete for females. The bigger, stronger males display bold patterns to attract attention. Dramatic stripes, aggressive flashes, the visual equivalent of flexing. Smaller males can't compete with those displays. They'd lose every fight. So they do something incredible. They split their body in half. On the side facing the female, they display the male courtship pattern. Bold, confident, attractive. On the side facing the bigger male, they display the female pattern. Calm, neutral, non-threatening. The dominant male sees them and thinks, no threat, just another female. He ignores them. And while he's distracted, the smaller male sneaks past him and approaches the actual female. He's sending two completely different messages from one body at the same time, to two different audiences, each one tailored to manipulate the receiver in a specific way. This is a level of social deception that exists in maybe a handful of animals on Earth. Most of them have backbones. Many of them have higher cognition by traditional measures. And here's a soft-bodied invertebrate doing it casually every mating season with its skin. Now let's zoom out for a moment. Because the more I learn about the cuttlefish, the more I think we have to redefine what we mean by intelligence. We usually think of intelligence as something happening inside a brain, hidden behind eyes, inside a skull, private. But the cuttlefish thinks out loud. When the cuttlefish processes a threat, its skin changes. When it identifies prey, its skin changes. When it tries to attract a mate, its skin changes. When it considers two different audiences, its skin changes differently on different sides. Its mental state is visible, broadcast in real time across its body. You can literally see the cuttlefish thinking. Imagine if humans were like that. Imagine if every emotion, every decision, every shift in your focus showed up as visible patterns on your skin. Other people would always know exactly what you were thinking. That's the world the cuttlefish lives in. Its mind is not private. Its mind is its skin. And in some way I don't fully understand. That means its consciousness is distributed across its entire body. Its thoughts aren't trapped inside a skull. They're spread out, visible, public. It's such a different way of being a living creature. There's one more thing I want to share with you. And honestly, this one gets me every time. Scientists have run experiments on cuttlefish that test for something called delayed gratification, the ability to wait now for a better reward later. This is one of the classic tests of intelligence in children. You give a 4-year-old a marshmallow. You tell them, if you don't eat it for 15 minutes, you'll get a second marshmallow. Most young children fail. They eat the marshmallow immediately. It's a famous experiment. They ran a version of this test on cuttlefish. The cuttlefish passed. When given the choice between a small immediate reward and a larger reward they had to wait for, the cuttlefish chose to wait. A cuttlefish has the impulse control of a human child. I don't know how to fully process that, but I think about it often. Because if a soft-bodied marine invertebrate can wait for a better reward, what does that say about the level of cognition swimming around in our oceans? We're surrounded by minds we barely understand. The cuttlefish is one of the strangest, most fascinating creatures on this planet. It is technically vulnerable, soft, slow, easily eaten. No shell, no teeth, no armor, and yet it survives. Because it figured out something profound about evolution. When you can't outfight your enemies, outthink them. When you can't outrun them, out-illusion them. When you can't be invisible, become the background. The cuttlefish is what happens when an animal traded armor for processing power. When it spent millions of years evolving not bigger muscles or sharper teeth, but a better visual system, a faster nervous system, and a body that could think out loud. The result is one of the closest things to alien intelligence on Earth. Somewhere right now, on a reef on the other side of the planet, a cuttlefish is hovering above the sand. Its skin is rippling, calculating, reading the light, translating its environment into patterns nobody but it understands. To a passing fish, it's invisible. To a curious crab, it's just texture on the seafloor. To another cuttlefish, it's broadcasting 100 silent messages. To us, if we're lucky enough to spot it, it's a creature thinking out loud, in real time, in a language written on flesh, the living screen. A reminder that intelligence on this planet didn't just evolve once. It evolved in radically different forms, in radically different bodies, with radically different rules. And some of those forms, we are only just beginning to understand. Okay, I need to tell you about an animal that, I swear, sounds like someone made it up. It's small, about the size of your hand, looks like a colorful little shrimp. It punches with the force of a bullet. It sees colors we don't even have names for. And its eyes work in ways that violate everything biologists thought they knew about vision. This is the mantis shrimp. And honestly, I had to stop and verify the facts multiple times while researching this chapter, because every single thing I'm about to tell you sounds impossible. But it's all real. This little creature is, hands down, one of the strangest animals ever discovered. By anyone. Anywhere. Let me show you why. Let's start with the punch, because this is where it gets ridiculous. The mantis shrimp has two specialized appendages, folded under its body like a praying mantis, hence the name. When it strikes, those appendages unfold and accelerate forward at a speed that, when scientists first measured it, they thought their equipment was broken. The mantis shrimp punches at roughly 80 kilometers per hour. Underwater. Let me say that again, because it doesn't fully register the first time. Underwater. Where you and I can barely move our arms quickly. Where water resistance slows everything down by a factor of hundreds. This shrimp moves its little arms so fast that water itself can't get out of the way. And here's where it gets really wild. When the mantis shrimp punches that fast, it creates something called cavitation. Cavitation is what happens when liquid moves so fast it actually vaporizes. The pressure drops so dramatically that bubbles form spontaneously in the water, and then those bubbles immediately collapse, releasing a second shockwave of force. So when the mantis shrimp punches a snail, it hits the snail, and then a tiny implosion happens behind the punch and hits the snail again. Two shockwaves, from a single strike, from an animal smaller than your hand, and the collapsing bubbles. They briefly reach temperatures of thousands of degrees, hotter than the surface of the sun, for a microsecond. The mantis shrimp is, in a real measurable scientific way, boiling water with its fist. I'm not exaggerating. I'm not being dramatic. That's literally what's happening every time it hunts. How is this real? How does this exist? What kind of evolutionary path leads to a thumb-sized animal that creates star temperature reactions when it punches? I genuinely don't have an answer. Nobody does. It's just one of those facts about nature that sits there staring back at you, refusing to make sense. Now, fair question. How does an animal this small avoid destroying itself when it punches that hard? The answer is another piece of impossible engineering. The mantis shrimp's punch doesn't come from muscle power directly. Muscles aren't fast enough to generate this kind of acceleration. Instead, the mantis shrimp uses a spring-loaded mechanism. The muscles slowly compress a saddle-shaped piece of its exoskeleton, basically winding up a biological spring. A small latch holds everything in tension. When the shrimp wants to strike, it releases the latch. The energy stored in that compressed spring releases all at once. The arm shoots forward at impossible speed, and the impact is absorbed by special layered armor in the appendage itself, material so unique that engineers are now copying its structure to build better body armor for soldiers. Yes, really. There are research labs right now studying mantis shrimp appendages to make better helmets and armor for humans. This little crustacean has solved engineering problems that our best material scientists are still trying to catch up to. Okay, the punch is wild. We've established that. But the punch isn't even the most impossible thing about this animal. Wait until I tell you about the eyes. You and I have 3 types of color receptors in our eyes: red, green, and blue. That's it. Every color you've ever seen in your entire life, every sunset, every painting, every photograph, is built from combinations of those 3. 3 receptors. That's our entire visual experience. The mantis shrimp has 16 different types of color receptors. For decades, Scientists couldn't even imagine what that would look like. We assumed it must mean the mantis shrimp sees a hyper-detailed rainbow universe, colors so rich and varied that human vision would look like grayscale by comparison. And then we ran experiments to find out. The results were shocking. It turns out the mantis shrimp doesn't see more colors in the way we expected. Instead, it uses those 16 receptors as a kind of instant scanning system. It doesn't compare colors the way we do. It identifies them directly. Imagine if you could glance at a fruit and immediately know, without thinking, without comparing, exactly what color it is. No processing time, no calculation, just instant recognition. That's what the mantis shrimp does. 16 receptors, 16 channels, instant classification. The mantis shrimp doesn't see the world more beautifully than we do. It sees the world more efficiently than we do. It's like comparing a person reading slowly through a book to a computer scanning the same book in milliseconds. Different system, different speed, different goal. But honestly, the receptor count isn't even the strangest thing about its vision. The mantis shrimp can also see polarized light. Polarized light is something most of us only encounter when we put on polarized sunglasses to cut glare from water. It's an aspect of light invisible to the human eye. We literally cannot perceive it. The mantis shrimp sees it natively, all the time. But it gets more impossible than that. The mantis shrimp can also see circularly polarized light, a specific type of light spiral that, before scientists studied this animal, no other creature on Earth had been observed to detect. For most of evolutionary history, circularly polarized light was assumed to be biologically invisible, a property of physics that no living thing could perceive. The mantis shrimp sees it as easily as we see the color red. How? Why? What is it using this superpower for? The leading theory is that mantis shrimp signal to each other using polarized light patterns, sending visual messages that no predator, no rival, no other species can read. It's basically a secret language written in light. The mantis shrimp evolved its own encrypted communication system. In light wavelengths, nothing else can see. I find that genuinely beautiful. The idea that there's a whole conversation happening in our oceans, right now, in a part of the light spectrum that's invisible to almost every other creature on Earth. Now the eyes themselves, physically, are also bizarre. The mantis shrimp has stalked eyes that move independently. Each eye can rotate in a different direction, look up while the other looks down, track two different objects at once. But each eye is also divided into three sections: top, middle, bottom, and each section can see independently. So a single eye on a mantis shrimp can perform three-dimensional depth perception by itself. Read that again. Most animals, including humans, need two eyes to judge distance. We compare the slightly different images each eye sees, and our brain calculates depth from the difference. The mantis shrimp does this with one eye, which means it has trinocular depth perception from a single eye, while each eye moves independently, while processing 16 color channels and multiple types of polarized light simultaneously. There is no other animal on Earth that comes close to this kind of visual system. The mantis shrimp's eyes are arguably the most advanced visual organs in the entire animal kingdom. In an animal the size of your hand, living in a hole in the seafloor. I'll never get over how absurd that is. Okay, I have to share one more thing with you about this animal, because this part actually makes me laugh. There's a species of mantis shrimp known among marine biologists as the peacock mantis shrimp. It's bright, colorful, beautiful, and notoriously aggressive. Aquariums have a serious problem with this species. Why? Because the peacock mantis shrimp will punch through the glass of its own aquarium tank. I'm not joking. This is a documented, real issue. Aquariums have to use specially reinforced glass for these animals. Regular tanks aren't safe. The shrimp can crack the glass with a single strike. There are recorded cases of mantis shrimp shattering the side of an aquarium, escaping into the building, and being found wandering through the facility hours later. You're holding an animal in your hand that punches like a small bullet. It doesn't care that it's underwater. It doesn't care that the glass is thick. It doesn't care that you're trying to study it. If it doesn't like its container, it goes through the wall. How do you not love this thing? Now I want to take a moment to appreciate something deeper here. Because the mantis shrimp isn't just a curiosity. It's not just a weird little punching machine with sci-fi eyes. It's a glimpse into how strange evolution can get when given enough time. Think about this. The mantis shrimp evolved for hundreds of millions of years in a specific environment. Coral reefs, sea floors, dim water, polarized light, armored prey. Every weird thing about it makes sense in that context. Its punch evolved to break shells. Its complex eyes evolved to spot prey in murky water. Its polarized vision evolved to communicate secretly with other mantis shrimp. Its spring-loaded mechanism evolved to bypass the speed limits of muscle. Every impossible feature is actually a perfect solution to a specific problem the mantis shrimp's ancestors faced. Nature doesn't waste anything. Every absurd-looking adaptation exists because somewhere in evolutionary history, it was the exact right answer to a question only that species was asking. It's beautiful when you sit with it. There's also something humbling about the mantis shrimp. For most of human history, we assumed our vision was the gold standard. We assumed our eyes were among the most sophisticated in nature. The mantis shrimp shattered that assumption. We now know, with certainty, that there are animals on this planet experiencing reality in ways we cannot even conceive of. Animals that see types of light we can't see, process information faster than we can, detect signals our nervous systems aren't built to register. We are not the most sensorily advanced species on Earth. We are not even close. The mantis shrimp doesn't know any of this. It doesn't realize how remarkable it is. It's just trying to find a meal, defend its burrow and not get eaten. Same as every other animal in the ocean. But what evolution gave it, to do that simple job, is one of the most magnificent biological machines ever assembled. Somewhere right now, on a coral reef in the Pacific, a mantis shrimp is sitting at the entrance of its little burrow. Its eyes are rotating independently, scanning the reef in directions you and I can't even imagine seeing at once, reading wavelengths of light we'll never perceive, detecting polarization patterns invisible to almost every other creature on Earth. Its body is small. Its world is small. But inside that small body is one of the most advanced sensory systems ever evolved, and one of the most powerful weapons ever scaled down to crustacean size. If a passing crab makes a mistake, if a snail wanders too close, that little spring-loaded fist will release. The water will briefly boil. The reef floor will tremble. And then everything will return to silence. Just a small shrimp, in its burrow, watching the world in colors nobody else can see. The impossible sensor. A reminder that the strangest minds and the strangest bodies on Earth are not in space. They're already here, just hidden under the waves. I want to slow down for a moment, because what I'm about to tell you about isn't a clever animal trick. It isn't an evolutionary curiosity. It's something much bigger than that. It's the closest thing on Earth, outside of us, to civilization. This is the orca, the killer whale. And by the end of this chapter, I think you'll understand why so many scientists who study orcas walk away from their research changed. Why some of them describe the experience as humbling. Why a few of them have even said, quietly, almost reluctantly, that they think orcas might be more human than we are. This isn't a documentary anymore. This is a portrait. Let me show you what I mean. Imagine a seal, alone, exhausted, terrified, clinging to a piece of floating ice in the cold waters of Antarctica. It thought the ice was safe. It thought predators couldn't reach it up there. It was wrong. Down below, 3 orcas have been observing it for several minutes. Calmly, silently. They've already chosen the seal. The decision was made before the seal even knew they were there. Now, one orca dives deep. The other 2 line up side by side, perfectly synchronized, picking up speed in formation. And then, together, they swim toward the ice. But they don't try to hit it. They don't try to break it. They use their massive bodies to push water. A wave forms in front of them. A wall of water, built deliberately with precision, moving toward the ice flow. The wave hits. The ice tilts. The seal slides. And on the other side of that ice, already in position, already waiting, is the third orca. Mouth open, eyes calm. What you just witnessed is not instinct. It is strategy. The kind of strategy that requires planning, coordination, role assignment, and trust. The kind of strategy that human special forces use. The kind of strategy that, until very recently, we believed only humans were capable of. But that's not even the part that gets me. The part that gets me is this: that hunting technique was not invented yesterday. It wasn't invented in the last 100 years. It has been passed down through orca generations for centuries. Mothers teach it to their children. Grandmothers oversee the lessons. Calves rehearse and practice, and slowly, over years, refine the technique. The same technique their great-great-great-great-grandmothers used. Orcas have traditions. They have what we, in any other context, would call culture. Let me explain why this matters so much. Because we used to believe culture was something only humans had. We thought it was what separated us from animals. The ability to pass down knowledge across generations. The ability to teach our children things we learned from our own parents. The ability to maintain traditions that span centuries. But orcas do this, casually, across the world, in ways we are only now beginning to document. And here's the part that still humbles me whenever I think about it. There isn't really one species of orca. Biologically, yes. But culturally, no. Different orca populations live completely different lives. Some pods specialize in hunting fish. They almost never touch mammals. They have specific vocal calls used only within their tribe. They follow specific migration routes their ancestors used. Other pods specialize in hunting seals, like the wave hunters we just watched. They never eat fish. They have entirely different traditions, different calls, different ways of being in the world. Some pods specialize in hunting sharks. I'll come back to that one in a minute, because that one is genuinely incredible. And here's what's remarkable. These different pods don't really interbreed, even though they're biologically the same species, even though they live in the same oceans. They stay separate. They speak different dialects. They keep their cultures intact. It's not just biology. It's identity, heritage, tradition. The scientific community now uses a word for orca societies that we never used to apply to non-human animals. Cultures, plural. The orca is not one species with one way of life. It is many cultures, living parallel lives in waters all over the world. Now let me come back to the shark hunters, because this is one of the most extraordinary things I've ever learned about any animal. Off the coast of South Africa, there is a specific population of orcas that has figured out how to hunt great white sharks. Yes, great whites, the most feared predator in the ocean. And the orcas don't just kill them. They've learned something far more sophisticated. They've discovered that if you flip a shark upside down, if you turn it onto its back in the water, it enters a state called tonic immobility. The shark's nervous system essentially shuts down. Its body goes limp. It can't fight back. It can't even swim. The orcas figured this out, and they've been passing this knowledge down through generations, for as long as anyone has been observing them. In some areas of South Africa, the orcas have killed so many great whites that the sharks have fled the region entirely, permanently. Just abandoned hunting grounds they had used for thousands of years. Let that sink in. The most feared predator in the ocean, the great white shark, runs away from these orcas. Not occasionally, not when threatened, permanently. Because the orcas are smarter, better organized, more coordinated. The shark is a soldier. The orca is a general. Let me tell you about the social structure of orca pods, because this is where you start to feel something deeper. Orcas live in family groups called pods. These aren't loose social groups. They are tight, lifelong, multi-generational families. Sons stay with their mothers for their entire lives. Daughters stay with their mothers for their entire lives. Grandmothers, mothers, sons, daughters, grandchildren. All swimming together, hunting together, communicating constantly. Some pods have stayed together as a single family unit for over 100 years. Imagine that. A family where nobody ever leaves, where you spend 100 years with the same group of people, where the woman who raised your grandmother is still swimming next to you when you're 40. That is the reality of being an orca. And it's not the mothers who lead these families. It's the grandmothers, the oldest females, the ones with the most experience, the ones who remember things that happened decades ago, the migration routes, the prey locations during droughts, the techniques that worked and the ones that didn't. The pod is led by wisdom. When a grandmother orca dies, the entire pod often suffers for years afterward. Not just emotionally, though that part is well documented, practically, because she carried knowledge no one else had. Knowledge that took her 70 years to accumulate. Knowledge that, when she dies with her. There is something deeply moving about this. The orca pod doesn't follow the strongest. It doesn't follow the fastest. It doesn't follow the most aggressive. It follows the wisest, the one who has seen the most. And if that sounds familiar to you, if that reminds you of your own grandmother, your own elders, your own family structure, that's not a coincidence. It means the orca and the human, separated by 90 million years of completely different evolution, arrived at the same answer to one of the deepest questions in nature. How do you keep a community alive across generations? You honor the oldest. You preserve their wisdom. You build everything around them. The orcas figured this out, long before we did. I want to share something with you that I genuinely cannot get through without feeling something. A few years ago, in the waters off Washington State, a female orca named Tahlequah gave birth to a calf. The calf died shortly after birth. What happened next stunned the world. Tahlequah refused to let her baby's body sink. She carried it on her head, pushing it through the ocean, day after day, slowing down for it, returning to it when she needed to surface to breathe. She carried her dead baby for 17 days, over 1,000 miles of ocean. Her pod stayed with her. Other females in the family swam beside her. When she got too tired to carry the baby, they took turns. They lifted it. They held it for her. For 17 days, an entire family of orcas slowed down to mourn one lost calf. Scientists watched. The world watched. People wrote articles. People cried. Because there's no scientific way to describe what we were seeing. There's no clean academic word for what those orcas were doing. The only word that fits is grief. A mother's grief. A family's grief. A community holding one of its members through the worst moment of her life. For 17 days. I think about that often. Because it tells me something that data alone cannot tell me. It tells me there is something in those animals. Something deep, something rich, something fully alive, that we are barely beginning to understand. Maybe orcas don't feel grief exactly the way humans do. We can't know that. But they feel something. Something profound enough to override 17 days of survival logic. Something profound enough to slow down an entire family. Something profound enough to make a mother carry her dead child until she could finally let go. And that, whatever it is, deserves our attention, our care, our respect. There is a darker side to all of this, though, and I have to tell you about it because it's important. As the apex predator of the ocean, the orca accumulates everything we dump into the water. Mercury, PCBs, microplastics, industrial pollutants. Every chemical in the food chain eventually concentrates in the bodies of the predators at the top. The top is the orca. And in some populations now, the contamination levels are catastrophic. There are orca pods where the chemical pollution in their tissues is so severe that when those animals die and
wash up on beaches,
Their bodies are classified as toxic waste. Read that again. Their bodies are toxic waste. A creature with the intelligence of a great ape, the social bonds of a human family, the cultural depth of a species that has survived for millions of years. We are poisoning them, not by killing them directly, not by hunting them, just by polluting the water around them. Slowly, year after year, the chemicals we make in our factories and dump into rivers and oceans accumulate inside their bodies. Some orca populations now have such severe contamination that they can no longer reproduce. Their calves die at birth or are born too weak to survive. Some entire pods may simply blink out of existence in the next few decades. Not because they are unintelligent, not because they failed to adapt, because we contaminated their world. What we lose when we lose an orca pod is not just a group of animals. We lose a culture, an entire library of inherited knowledge, hunting techniques passed down through hundreds of generations, dialects nobody else speaks, family histories, traditions, a way of being in the world that took thousands of years to build. You cannot recreate that. Once an orca pod is gone, it's gone forever. This is the part I struggle with the most when I think about orcas, because they are, in every meaningful way, our closest non-human peers on this planet. Their intelligence isn't a curiosity. Their family bonds aren't an accident. Their cultures aren't a metaphor. They are another civilization, living right alongside us. In the same oceans we cross with our ships, fish from with our nets, and pollute with our waste. And most of us go through our entire lives without ever thinking about them. If aliens visited Earth tomorrow and discovered orcas, they would consider them one of the most fascinating species on the planet. They would write about orcas the way we write about ancient civilizations. They would marvel at the inherited culture, the wisdom of the grandmothers, the dialects, the 17-day mourning rituals. We are the ones who got too used to them. We are the ones who forgot what we have. Right now, somewhere in the ocean, a pod of orcas is moving through cold blue water. The grandmother leads them. Her daughters swim beside her. Her grandchildren tumble and play in her wake. They are talking to each other, in dialects you and I will never speak, sharing stories we will never decode. They are teaching the young ones lessons that were taught to their great-great-grandmothers. In oceans their ancestors swam through thousands of years ago. They are not just animals. They are not just intelligent creatures. They are the closest thing the sea has to a civilization. The inherited tactics. A reminder that culture didn't begin with us. Family didn't begin with us. Wisdom passed across generations didn't begin with us. Sometimes I wonder, if we ever do meet another intelligent species in the universe, what they will think of how we treated the ones we already had on our own planet. Whether they will judge us, whether they will understand, whether they will mourn the orcas we lost, the way Tahlequah mourned her calf. For now, the orcas keep swimming, keep teaching, keep passing down knowledge older than human civilization itself. For now, I hope we get to keep them. I really do. Let me ask you something. When I say the words, great white shark, what's the first thing that comes to mind? Be honest. Probably teeth. Probably the music from Jaws. Probably the image of a massive mouth lunging out of the water. Maybe a memory of a documentary you watched as a kid that gave you nightmares. Maybe you've never wanted to swim in the ocean since. That image, that fear, has been carefully constructed over decades. Movies, sensational news stories, aquarium gift shops, tourism marketing, the killing machine narrative. And I'm going to tell you something that might be hard to accept. It's almost entirely wrong. The great white shark is one of the most misunderstood animals on this planet. And by the end of this chapter, I think you'll see why some marine biologists who study them say, without any hesitation, that the great white isn't a mindless killer at all. It's something far more sophisticated. And honestly, far more beautiful. Let me start by destroying the biggest myth. The great white shark does not hunt by accident. It does not blunder through the ocean swallowing anything that moves. It does not smell blood from miles away and go into a frenzy. What it actually does is incredibly precise. Picture this. A seal swimming peacefully near the surface. Nothing else around. The water is calm. The seal hasn't seen anything threatening. 3 kilometers away. 3 kilometers. A great white shark is already aware of it. Not by seeing it, not by hearing it, by something else entirely. The shark has been building a picture, slowly, methodically, using sensory systems that are so advanced they almost feel like science fiction. Let me walk you through them one by one. Because once you understand what a great white actually perceives, you start to realize you're looking at one of the most sophisticated detection systems in the natural world. System 1. Smell. A great white shark's sense of smell is something I had to read about multiple times before I really believed it. Roughly 2/3 of the shark's brain is dedicated to processing scent. Let me put that in perspective. Your brain has tons of regions for vision, for memory, for language, for movement. The shark's brain? Most of it is just for smell. A great white can detect a single drop of blood diluted in millions of drops of water. Not nearby, from over a kilometer away. Some studies suggest even further. But here's the part most people don't know. The shark doesn't just detect blood, it detects direction. Because the shark has 2 nostrils on either side of its snout, it compares the strength of a scent reaching the left nostril versus the right. If the scent is slightly stronger on the left, it turns left. Stronger on the right, it turns right. By making constant tiny adjustments, the shark moves directly toward the source. This isn't smell the way you and I experience it. This is triangulation. The shark is doing real-time math with chemistry. Every molecule of scent reaching its nose becomes a coordinate in an invisible map. System 2. Vibration. Along both sides of a great white's body runs a structure called the lateral line. It's basically a row of microscopic motion detectors embedded under the skin. These detectors don't sense sound the way our ears do. They sense water displacement, the tiny waves and pressure changes that ripple through the ocean every time something moves. The lateral line can detect a fish flicking its tail from over 100 meters away. But it does more than detect motion. It identifies patterns. A seal swimming smoothly creates a slow, rhythmic wave pattern. An injured fish thrashing creates chaotic, irregular pulses. A diver kicking generates yet another distinct signature. The shark doesn't just feel motion, it reads what kind of motion. It can tell the difference between a healthy seal and a wounded one without ever seeing them. Imagine if your skin could distinguish between the footsteps of different people walking in your house, from a different floor, through walls. That's what the shark's lateral line does, in 3 dimensions, through water, all the time. System 3. Vision. This one's interesting because the shark's vision is not better than a human's in the way you might expect. Great whites don't see in vivid color the way we do. They're not built for sharp focus across long distances. In fact, their eyesight is fairly average for an underwater predator. But what they can see is contrast, especially the contrast between dark shapes and bright surfaces. When a seal is at the surface, viewed from below, it looks like a dark cutout against a bright ceiling of sunlight. To the shark's eyes, that contrast lights up like a spotlight. This is why most great white attacks happen from below. The shark isn't sneaking up from the depths because it's dramatic. It's doing it because from below, prey is at its most visible. Once the shark gets close enough, vision takes over from the other senses and confirms the strike target. And here's a weirdly intimate detail. At the exact moment of impact, the great white rolls its eyes back in its head to protect them from struggling prey. It's literally striking blind in the final split second, trusting all its other senses to deliver the kill. System 4. Electricity. This is where things get genuinely strange. Around a great white's snout, in clusters under the skin, are tiny gel-filled organs called the ampullae of Lorenzini. You can't see them from a distance. They look like small dots if you look closely at a shark's face. These organs detect electricity. Every living creature in the ocean generates a faint electrical field. Your heartbeat creates electricity. Your muscles contracting create electricity. Your nervous system constantly generates tiny electrical signals. The great white shark can sense those signals. Read that again, slowly. It can sense the heartbeat of a seal from several meters away. Even prey buried completely under sand, fish hiding, completely invisible, can be detected by the shark just from their electrical signature. There is no other major predator on land that has anything close to this ability. We are, as a species, totally electrically blind. The shark sees a layer of reality that we cannot even perceive. When you put all four systems together, smell, vibration, vision, electricity, the great white is essentially running on four parallel detection systems at all times, cross-checking, verifying, building a complete sensory picture. This is not a mindless killing machine. This is a sensor platform. The most advanced biological detection system in the ocean, possibly on Earth. Now let me tell you something that might surprise you. Great white sharks are cautious. I know that doesn't fit the image, but it's true. When a great white targets prey, it doesn't just rush in. It commits to a strike only when its sensory systems agree, when smell, vibration, vision, and electricity all confirm that the target is high value, low risk, and worth the energy expenditure. This is why most shark attacks on humans are not predatory. They're investigative. A great white that bites a surfer and immediately swims away isn't trying to eat the surfer. The shark is doing what we'd call a taste test. Sharks don't have hands. They explore the world with their mouths. When they encounter something unfamiliar floating at the surface, they take an exploratory bite and then almost always release. Surfers, paddleboarders, and divers don't taste right. Not enough fat, not enough calories, not worth the chase. The myth of the shark going into a frenzy and devouring humans is, overwhelmingly, not true. Most people who survive shark bites do so because the shark chose to let them go. It made a calculated decision that the human wasn't worth eating. Think about that. The animal you were taught to fear most actively decides to spare you. Not because of mercy, because of economics. Because every meal has to justify the energy spent catching it. This is not a frenzied predator. This is a careful, calculated investor in its own survival. I want to share something with you that genuinely changed how I view this animal. Great white sharks can live for over 70 years, maybe even longer. The exact lifespan is still being studied, but what we know is that they grow slowly, mature late, reproduce rarely, and carry decades of experience in a single individual. A 70-year-old great white shark has lived through more ocean change than any human you'll ever meet. It has felt the temperature of the sea shift, watched migration patterns evolve, followed prey populations through booms and collapses. It has hunted in waters humans have never seen, and it has done this with a body that hasn't changed significantly in over 400 million years. Sharks predate dinosaurs. They predate trees. They predate Saturn's rings, which formed roughly 100 million years ago, long after the first sharks were already swimming the oceans. Every great white shark alive today is the descendant of a lineage that survived multiple mass extinctions, 5 of them. Events that wiped out 75% to 95% of all life on Earth each time. The asteroid that killed the dinosaurs? Sharks were already there, and they were there afterwards. When you look at a great white, you are looking at one of the oldest, most successful designs nature has ever produced. A blueprint so effective it survived the death of the dinosaurs, the rise of mammals, the entire history of human civilization, and is still here, doing exactly what it has always done. We are, by comparison, brand new. The shark was here long before we figured out how to walk upright. If it had a memory long enough to compare us to itself, it would consider us a recent arrival. And here's the part that genuinely hurts to talk about. Despite all of this, despite hundreds of millions of years of survival, great whites are now in serious trouble. It's estimated that humans kill roughly 100 million sharks per year. Worldwide. Across all species. 100 million. Most of them for shark fin soup. For fishing bycatch. For trophies. For fear. In the time it took you to watch this chapter so far, several thousand sharks have died at human hands. Great whites specifically are protected in many countries now, but their numbers are still declining. They reproduce so slowly, taking decades to mature, that even moderate losses can collapse populations. We may be the first species in Earth's history capable of doing what asteroids, ice ages, and supervolcanoes couldn't do, ending the reign of the shark in a single century. I want to leave you with something to think about. For decades, the great white shark has been cast as the villain of the ocean, the monster, the killer. But everything I've shown you in this chapter, the 4 sensory systems, the careful calculations, the 70-year lifespans, the slow reproduction, the cautious behavior, the ancient evolutionary lineage, tells a completely different story. The great white isn't a monster, it's a survivor, one of the oldest survivors on this planet. It is not aggressive toward humans. It does not hunt us. The number of fatal shark attacks per year is so small that you are statistically more likely to die from a vending machine falling on you. More people are killed by cows each year than by sharks, by a wide margin. And yet, we kill millions of them every year while teaching our children to fear them. There's something tragic about that. We taught ourselves to be afraid of one of nature's most refined, ancient, and beautiful animals, and then we used that fear as an excuse to destroy them. The great white shark deserves better. It deserves to be understood for what it actually is. Not a killing machine. A walking, swimming sensory miracle. A creature so finely tuned to its world that it can feel a heartbeat through water, smell a single drop in an ocean, detect electricity, live for nearly a century, and do it all with a design that hasn't needed updating since before mammals existed. Right now, somewhere in the deep blue, a great white shark is moving slowly through cold water. Its sensory systems are all running quietly. Smell, vibration, vision, electricity. All 4 channels feeding information into its brain, building a constant picture of everything happening for kilometers around it. It's not hunting anything specific right now. It's just aware of every creature within range, of every current, of every heartbeat in the water. Its body is older than human civilization, older than language, older than the wheel. And it doesn't need any of those things to thrive. It just needs the ocean. And 400 million years of refinement. The hidden sensor grid. A reminder that the most ancient minds on this planet are not the ones we honor. They are the ones we fear. And maybe, just maybe, it's time to change that. I want to slow down for a moment. Because after the great white shark, after the orcas, the mantis shrimp, the cuttlefish, the octopus, we've spent this whole video looking at big, dramatic, awe-inspiring minds. But I want to show you something different now. Something small, something almost ignored, something that, honestly, most people in this world have never really stopped to think about. The seahorse. Yeah, the seahorse. The cute little curled-up creature you've probably seen in aquariums. The one decorating beach gift shops. The one your kids draw in school. I'm here to tell you that this little animal, this completely unassuming, ornamental-looking creature, is doing something with its tiny brain that, when I really sat down and studied it, made me see the entire ocean differently. Let me explain. Picture a seahorse. It's barely the size of your thumb. It floats upright in the water, swaying gently among blades of seagrass. Its tail is curled around one of those blades, holding itself in place. Its eyes, those funny little eyes that move independently of each other, scan the water around it. It looks fragile. It looks decorative. It looks like a piece of art that somehow learned to breathe. Now imagine a tiny copepod, a microscopic shrimp-like creature, drifting through the water nearby. The copepod is one of the fastest reactors in the entire ocean. When a predator approaches, copepods can launch themselves away in 2 milliseconds. 2 milliseconds. That's faster than almost any escape response in nature. So how does a slow, fragile, almost stationary seahorse, an animal that can barely swim, catch one of the fastest reacting creatures in the ocean? The answer is something I find genuinely beautiful. It doesn't chase. It doesn't pursue. It doesn't even move. It just waits and calculates, and then strikes with such surgical precision that the copepod never even has time to react. The seahorse, this tiny, harmless-looking little animal, is one of the most efficient ambush predators in the entire ocean, and it does it through pure timing. Let me describe how this strike actually works, because it's something special. The seahorse's head, the part that looks like a little horse face, is tilted downward, almost at a right angle to its body. That weird angle? It's not decorative. It's a trigger mechanism. The seahorse loads tension into specialized muscles in its neck, slowly, quietly, while the prey has no idea it's even being watched. When the moment is exactly right, the seahorse releases that tension all at once. Its head snaps upward in less than a single millisecond. A millisecond. 1,000th of a second. And as the head moves, its tubular snout creates a sudden vacuum. The water around the prey, and the prey itself, gets sucked into the seahorse's mouth before the prey's nervous system can even register what's happening. The strike is faster than the prey's escape reflex. Not by a little, by a lot. In a way, the seahorse is doing the same thing the Mantis shrimp does, using stored energy to bypass the speed limits of muscle. But where the Mantis shrimp uses a spring-loaded fist to smash prey, the seahorse uses a spring-loaded neck to gently inhale it. Two totally different solutions, same elegant physics. Now here's what fascinates me about the seahorse strategy. Most predators rely on either speed or strength. Sharks chase. Barracuda lunge. Orcas hunt in coordinated teams. The seahorse has neither. It's slow. It's weak. It's basically the worst designed fish in the ocean if you're measuring it by speed or power. But it has something else. Something that, on its own scale, is more important than either. Position. The seahorse spends its entire life choosing the right spot. Not the obvious spots. The specific spots where the ocean's currents naturally funnel plankton past a fixed point. Tiny, invisible highways of food. It finds those locations. It anchors itself there. And then it just waits. The current does the work. The plankton drifts by. The seahorse strikes. This isn't laziness. This is understanding. The seahorse has mapped, in its tiny brain, the hydrodynamics of its environment. It knows where the prey will come from. It knows when. It knows how. And it positions its body so that its strike is essentially guaranteed. While bigger predators are spending massive energy hunting, the seahorse is spending almost zero energy receiving. It has turned hunting into a kind of passive equation. The food comes to it. The strike is just the final mathematical certainty. I think that's brilliant. Honestly, in its own way, it's as sophisticated as anything the orca or the cuttlefish does. But there's something else about the seahorse I want to share with you. Something I find deeply moving. The seahorse doesn't try to be invisible the way a cuttlefish does, by changing color. It tries to be invisible by becoming part of the environment. Watch a seahorse in a seagrass meadow. As the seagrass sways in the current, the seahorse sways with it, in perfect synchrony. Its body rocks at exactly the same rhythm as the plants around it. It's not just camouflage. It's mimicked motion. Because here's the thing. Plankton and small fish don't just look for shapes. They look for unusual movement. Anything that moves differently than the background gets flagged as a threat. So the seahorse solves that problem in the most elegant way possible. It moves with the seagrass. It becomes a piece of the rhythm, just another blade swaying in the current. By the time the prey realizes one of those swaying blades isn't actually seagrass, it's already inside a seahorse's mouth. The seahorse doesn't hide. It belongs. There's something almost philosophical about that. Most predators try to stand out from their environment or hide from it. The seahorse does neither. It becomes one with the environment so completely that it stops registering as separate from it. I think there's wisdom in that, if you sit with it long enough. Now I have to tell you about the strangest thing seahorses do. And this part might genuinely surprise you. In every species of seahorse on Earth, the males get pregnant. Yes, I mean that literally. The male seahorse carries the developing babies inside his body until they're born. Read that again, slowly, because it sounds made up. In seahorses, the female lays her eggs into a special pouch on the male's belly. The male then carries those eggs, fertilizes them inside his own body, provides oxygen and nutrients to them, regulates the temperature, salinity, and chemistry inside the pouch for weeks. And when the babies are ready to be born, the male goes into actual labor, contractions, pushing, the whole process. Hundreds of tiny seahorses are born directly from the father's body. This is real. This is documented. This has been filmed countless times. The seahorse is, as far as we know, the only animal on Earth where males truly experience pregnancy and birth. Think about how unusual that is. In every other species, including humans, including dolphins, including orcas, biological motherhood is a female thing. Pregnancy is a female thing. Giving birth is a female thing. Except in seahorses, where the entire script is flipped. Why? Nobody knows for sure. The leading theory is that this arrangement allows female seahorses to produce more eggs faster. She lays one batch, the male carries it, she immediately starts producing another batch. By splitting reproductive labor, the species can produce more offspring than either parent could alone. But however it evolved, there's something quietly beautiful about it. A species where fatherhood is not just provider, but literal carrier of life, where the male doesn't just protect the babies, he becomes them. He carries them inside his own body until they're ready to swim. And there's one more thing about seahorses I have to share, because it's the part that genuinely changed how I see this animal. Seahorses mate for life. In most seahorse species, once a male and female pair up, they stay together, sometimes for years, sometimes for their entire lives. They live in the same small territory. They greet each other every morning with a synchronized dance, rising up through the water together, changing colors, intertwining their tails. Every morning, for their entire life. Scientists call this the morning greeting dance. It happens at sunrise. The pair finds each other in their shared territory, links tails, and dances together in slow circles. It strengthens the bond between them. It reaffirms their connection. If one partner dies, many seahorse species refuse to find a new mate. This is a creature smaller than your thumb. A creature most people consider a decoration. A creature most of us have never thought twice about. And it has one of the most devoted partnerships in the entire animal kingdom. I don't know what to do with that information, except sit with it, quietly, and feel a little humbled. We tell ourselves stories about love, partnership, devotion. We think these are uniquely human things, or at least things that belong to higher animals like primates and birds. The seahorse is none of those things. It's a primitive fish in a strange shape. By every measure of intelligence we use, it's nowhere near the top. But somehow, it learned how to love just one creature for its entire life, with morning rituals that look almost like prayer. Why am I spending so much time on the seahorse? Because I think it teaches us something important. We tend to admire the loud minds, the dramatic hunters, the powerful predators, the orcas and the great whites and the octopuses with all their flashy intelligence. But there's another kind of intelligence in the ocean. Quieter, slower, more patient. The seahorse's mind is not about solving puzzles or coordinating attacks. It's about fine-tuning, knowing exactly where to be, exactly when to strike, exactly how to move so that nothing notices you, exactly which seagrass blade to anchor to, exactly which partner to spend your entire life with. Its intelligence as precision, as attunement, as being fully present in one small place. The seahorse doesn't need to be everywhere. It doesn't need to be powerful. It just needs to understand its one small patch of seagrass completely and perfectly. And in that smallness, in that complete devotion to a tiny piece of the ocean, there is a form of mastery the bigger animals can never have.
there's a darker side to the seahorse's story too, and I think it's important to mention. Seahorses are in serious trouble. Habitat destruction has decimated seagrass meadows around the world. Coastal development is removing the very environments they need to anchor in. Pollution is killing the plankton they feed on. And then there's the trade in dried seahorses. Tens of millions of seahorses are caught every year, most of them for use in traditional medicine, despite no real evidence that they have medicinal value. Others are dried and sold as souvenirs. Others are caught for the aquarium trade. It's hard to say exactly how many seahorses are left. Many species are now considered vulnerable or endangered. These devoted little creatures, these lifelong partners, these precision ambushers, these gentle, quiet minds, are quietly disappearing from the oceans. Most people will never notice. That's the saddest part of all of this. The seahorse is so small, so quiet, so easily overlooked that even its extinction might not get the headlines it deserves. I hope that changes. I hope chapters like this one, and viewers like you, start paying attention. Because we're not just losing animals, we're losing entire ways of being in the world. Somewhere right now, in a seagrass meadow on the other side of the planet, a seahorse is hanging onto a single blade with its tail. Its tiny body sways in perfect time with the current. Its eyes scan the water around it, independently, in two different directions at once. Nearby, anchored to another blade, is its mate. They've probably been together for years. Tomorrow morning at sunrise, they'll meet in the middle of their little territory and dance. Right now, though, both of them are just waiting, watching, calculating, listening to the rhythm of the ocean. And eventually, when a tiny copepod drifts past at exactly the right angle, the seahorse's head will snap upward in a fraction of a millisecond. The strike will be over before the prey understands it has begun. The water will settle. The seagrass will keep swaying, and the seahorse will return to its silent, patient watch. Small, quiet, easy to miss. But inside that tiny body is one of the most precisely tuned minds in the ocean, the precision ambush mind. A reminder that not all intelligence roars. Some of it whispers. And the whispers, if you stop and really listen for them, are sometimes the most beautiful sounds in nature. Okay, I need to share something with you that I genuinely had to research 3 different times before I was willing to put it in this video. Because every time I read about it, I assumed I was misunderstanding something, or that there was an exaggeration somewhere, or that scientists were using a metaphor. They weren't. This is real. There is an animal on our planet, alive, swimming, common in the world's oceans, easily filmed in the wild, that has 2 complete sets of jaws. 2. Not one mouth with extra teeth, not a clever overlap of bones. 2 separate, fully functional, independently movable sets of jaws. One in its mouth, one inside its throat. And when it catches prey, the second set of jaws shoots out, grabs the food from inside the mouth, and drags it down the throat. I'm not describing science fiction. I'm not describing a creature from a horror movie. This is the Moray eel, a real animal, swimming in coral reefs right now, as we speak. And the more you learn about it, the more you realize that nature is honestly so much weirder than anything humans have ever imagined. Let me back up and properly introduce this creature. The Moray eel looks like a snake had a baby with a fish. Long, muscular body. No scales, just smooth, slimy skin covered in protective mucus. Eyes that are small, almost beady. And a mouth that, when you see it open, looks like something out of a nightmare. There are over 200 species of Moray eels. Some are small enough to fit in your hand. Others, like the giant Moray, can grow up to 3 meters long and weigh as much as a person. They live in cracks, holes in the reef, tunnels between coral. Their bodies are so flexible they can squeeze into spaces no other predator can access. And once they're in there, they own that territory. Most predators in the ocean hunt by moving through the world. Sharks swim, octopuses prowl, orcas patrol. Morays don't do that. Morays anchor. A moray picks one crack in the reef and basically claims it as its kingdom. Some morays live in the exact same hole for decades. A single eel might spend its entire life in one tiny space the size of a coffee mug. It's a strange life, but it works. For tens of millions of years, it's been working. Now, let me explain the jaws, because this is where things get genuinely unbelievable. Most fish, almost all of them, eat by sucking. Picture how a fish swallows food. It opens its mouth and creates suction. The water and the food get pulled inside. This is how 95% of fish on Earth feed. But suction needs space. You need a big, wide mouth that can expand to create that vacuum. Suction feeding doesn't work in narrow spaces, and it doesn't work for animals with long, thin heads, like the moray. The moray's head is too long and too narrow to generate suction, so evolution had to find another way to get prey down its throat. What it came up with is, in my opinion, one of the most creative solutions in the entire animal kingdom. The moray eel's first set of jaws, the ones you can see from outside, work like normal fish jaws. They open, they close, they grab prey with sharp, curved teeth. But here's the problem. Once the moray bites a fish, it can't swallow it. There's no suction to pull the food down. The eel is just holding a struggling fish in its mouth, and if it lets go to reposition, the prey will escape. So what evolution did was completely insane. It took the moray's gill arches, the bony structures in the throat that originally helped fish breathe, and slowly, over millions of years, turned them into a second mouth. A second mouth, inside the throat, with its own muscles, its own teeth, its own ability to launch forward, grab the prey from inside the outer mouth, and drag it backward into the esophagus. When the moray bites a fish, the second jaws shoot out from the throat, lunge forward into the mouth, sink their teeth into the prey, and pull, like a tiny internal grappling hook reaching out to drag the food down. I'll be honest with you, the first time I read about this, I thought it was a joke. I thought someone was making it up. It sounded too bizarre to be real, but there's video of it. Real video. You can watch it happening in slow motion. The second set of jaws emerging from the back of the moray's throat, reaching forward into the mouth cavity, grabbing the prey, and retracting. It looks like something from a sci-fi movie about alien predators, except it's been here, swimming in our oceans, for millions of years. The closest comparison I can give you is to think about the alien from the Alien movies. You know, that creature with the inner jaws that shoot out from its mouth. That entire iconic design, one of the most famous monsters in cinema history, was inspired by the moray eel. Literally. H.R. Giger, the artist who designed the alien, was inspired in part by real biology. The second mouth wasn't his invention. It was already here on Earth. He just turned it into a horror movie villain. Most people don't realize this. They watch Alien and think the design is creative imagination. It's not. The most terrifying creature in science fiction is a slightly tweaked moray eel. Now, there's something really interesting I want to explain. Because the moray's two jaws aren't just weird. They're a brilliant evolutionary solution. Think about why the moray needs them. The moray lives in narrow cracks, tight tunnels, spaces where it can't open its mouth wide, spaces where it can't generate suction, spaces where, frankly, most predators couldn't feed at all. But the moray adapted. It found a way to feed despite its anatomical limitations. Instead of evolving better suction, it evolved a grabbing mechanism. Instead of pulling food in with water, it reaches out with a second set of teeth and physically transports the food backward. The moray isn't just a freak of nature. The moray is what happens when evolution gets clever. And honestly, I think this is one of the most elegant solutions to a biological problem I've ever seen. Faced with a constraint that should have made the moray a failed design, evolution doubled down, built a second weapon system, made it work anyway. The moray reminds us that nature doesn't always solve problems the obvious way. Sometimes it solves them in ways that look impossible. But the strangeness doesn't stop there. There's something else about the moray that almost everyone misunderstands. If you've ever watched a moray eel video, you've probably seen it sitting in its hole, mouth open wide, teeth bared, looking like it's about to attack. This is the most common image of the moray. It's used in documentaries, in aquariums, in horror imagery. The always open, angry mouth. Here's the thing. That's not aggression. That's just how it breathes. Most fish swim constantly, so water flows over their gills. The moray doesn't swim. It spends most of its life motionless inside a hole, so it can't passively breathe like other fish. What it does instead is rhythmically open and close its mouth every couple of seconds, pumping water across its gills manually. It's basically the moray's version of breathing. That terrifying, gaping mouth full of sharp teeth. It's just an eel doing the equivalent of inhaling and exhaling. It's like seeing a person yawn and assuming they're about to bite you. Once you know this, you can never look at a moray eel the same way. They go from looking like furious monsters to looking like slightly grumpy fish quietly trying to breathe. It's almost cute when you reframe it. Almost. Now, I want to share something with you that completely changed how I view morays. For decades, scientists believed morays were solitary predators, pure ambush hunters, coiled in cracks, waiting for prey, antisocial, aggressive. Then in the early 2000s, marine biologists started filming something nobody expected. Morays were hunting cooperatively, with groupers. A grouper, a completely different species of fish, would swim up to a moray's hole and do something bizarre. It would shake its head rapidly, side to side, almost like a dance. Scientists studying this realized it was a signal. The grouper was asking the moray for help. You see, groupers are good at catching fish in open water, but they can't get into tight reef cracks. Morays are good at getting into cracks, but bad at catching fish in open water. The two species, separated by hundreds of millions of years of evolution, figured out they were complementary. So they teamed up. When the grouper signals, the moray follows it through the reef. The grouper finds a fish hiding in a crack. The moray slithers in. The fish panics and bolts out the other side, right into the grouper's mouth. Whoever catches it, eats it. Simple deal. This is interspecies cooperation. Two completely different animals, communicating, coordinating, hunting together with mutual trust. Until this was filmed, we didn't think fish could do this. We thought this kind of cross-species teamwork was reserved for highly intelligent mammals, dolphins, primates, that kind of thing. But here was a moray and a grouper, working together, as partners, casually, probably for millions of years before any human ever saw it. The brutal ambush predator reputation. It's not the whole truth. The moray is also a collaborator, a teammate, a negotiator. It just hunts with someone who looks completely different from it. Here's another thing about morays that surprised me. They tolerate cleaner fish inside their mouths. Tiny little wrasses and shrimps swim right up to a giant moray with its massive teeth and walk around inside the eel's open mouth, picking parasites off the teeth, cleaning dead tissue from the gills. The moray doesn't bite them, doesn't even flinch, just lets these tiny creatures crawl around in its jaws, completely defenseless, knowing they're providing a service. It's a truce, an ancient, unspoken agreement. Inside the moray's mouth, nobody gets hurt. Think about how much trust that requires. A small fish, basically inside the mouth of a giant predator, doing dental work, while the predator just waits patiently. The moray could close its jaws at any moment and kill the cleaner instantly. But it doesn't. Ever. Because both species understand the deal. In a brutal, competitive ocean, there are rules. Even the scariest-looking predators follow them. The moray is terrifying, but it's also a creature that has learned how to cooperate, how to negotiate, how to live in a complex social web. I want to close this chapter by sharing one more thing I learned about morays that I think captures something true about all of nature. Morays can recognize individual humans. In areas where divers regularly interact with wild morays, feeding them, photographing them, observing them, the morays develop preferences. They greet certain divers by emerging from their crevices. They ignore divers they don't know. In some cases, and this is documented, they form long-term relationships with specific human researchers, returning to the same person across multiple years. I find that quietly beautiful. This snake-like creature, with its second set of jaws and its terrifying reputation, also capable of recognizing faces, remembering relationships, and forming preferences about which humans it likes. The most monstrous-looking animal in the reef has friends. It's almost romantic, in a strange way. The Moray eel is one of nature's strangest experiments. 2 sets of jaws, no scales. A body built like a snake, but a brain built for fish. Lives in cracks, hunts in tunnels, breathes by pumping its mouth, cooperates with groupers, tolerates cleaner fish, recognizes divers. A predator that has perfected the art of being many things at once, solitary and social, brutal and cooperative, terrifying looking and surprisingly gentle. Evolution didn't have a plan when it built the Moray. It just kept solving problems, and the Moray is what emerged after 100 million years of those solutions stacking up on top of each other. The result is an animal that, the more you study it, the more you realize shouldn't exist. The 2-jaw system alone is so strange that if a science fiction writer invented it, you'd say they were being unrealistic. But here it is, real, common, hiding in reef cracks all over the world, just doing its quiet, weird, brilliant thing. Somewhere right now, on a coral reef in the Pacific, a moray eel is curled inside a crack in the rocks. Its mouth opens. Its mouth closes, slowly, rhythmically, breathing. Its small eyes scan the water. A current carries chemical signals across its olfactory receptors. It's reading the reef through smell, building a constant map of every fish, every crab, every potential meal nearby. A small fish, fleeing from something larger, darts toward what looks like a perfect hiding spot, a dark crack in the rocks. It bolts inside, and the crack comes alive. The outer jaws snap. The inner jaws lunge. The prey vanishes into darkness before it even understands what just happened. The Moray returns to stillness, breathes, waits, for decades if it has to. The hidden weapon system, a reminder that the most absurd-looking animals in the ocean are often the ones with the most brilliant designs, and that nature, given enough time, will solve any problem, even if the solution looks like it came. There's a moment in every dolphin documentary where the dolphin makes eye contact with a human. You've seen it. I've seen it. Maybe you've even experienced it yourself if you've ever swum near them. The dolphin turns its head, looks at you, and something happens. You can't quite explain what, but suddenly you feel like the animal you're looking at is looking back. Not the way a fish looks at you, not the way an octopus looks at you. Different. There's a presence behind those eyes, a someone. It's so unsettling, in such a beautiful way, that humans have been writing about it for thousands of years. Ancient Greeks, Pacific Islanders, indigenous coastal communities everywhere. They all notice the same thing. Dolphins look at us like they know us. And after spending a long time researching this final chapter, I think they do. Maybe not the way another human knows you, but in some real, genuine, scientifically measurable way. The dolphin is reading you, listening to you, understanding you. And what they understand might surprise us if we could ever fully hear it back. We've come a long way in this video. We started with the octopus and its 8 separate brains. We met the cuttlefish that thinks out loud across its skin. We saw the mantis shrimp with vision no human will ever experience. We watched the orca pass down hunting techniques across centuries. We learned about the great white shark's 4 parallel sensory systems. We sat quietly with the seahorse and its precision ambush. We marveled at the moray eel's hidden second jaws. 8 different minds. 8 different ways of being intelligent. 8 different solutions to the same question evolution keeps asking:
How do you survive in the ocean? And now we end with the dolphin. Because the dolphin represents something none of the others do. The dolphin represents us. Not literally. Obviously, dolphins aren't humans. But the way they survive, the way they think, the way they navigate their world. It's the closest thing to human cognition we've ever discovered in another species. And when you really sit with what they can do, it's hard not to feel like we're looking into a mirror. Let me show you what I mean. You and I survive through social intelligence. Most of what makes humans special isn't our individual abilities. We're not the strongest, not the fastest, not the most fertile, not the largest. What makes us special is that we live in groups, communicate with sophisticated language, cooperate on complex tasks, build long-term relationships, and pass knowledge through generations. We are social readers. Our entire existence is built on understanding each other. Dolphins are exactly the same. A dolphin alone is not particularly impressive. A dolphin in a pod is one of the most coordinated, communicative, strategic predators on Earth. Let me describe how they hunt. Because once you see this, you start to realize you're not looking at fish behavior. You're looking at something else. A pod of dolphins finds a massive school of sardines, thousands of small fish moving as one. Now, if you or I were trying to catch a few sardines from a school like this, we'd panic. The school is constantly moving. The fish are flashing in synchronized patterns specifically designed to confuse predators. They scatter and reform instantly. The dolphins don't panic. They circle, slowly, methodically, from different angles. Some swim below the school, releasing streams of bubbles that rise up like a curtain. The sardines instinctively swim away from the bubbles, but the dolphins below have created a moving wall. The school gets pushed upward. Other dolphins are above the school, doing the same thing from a different angle, squeezing the sardines from above. A third group of dolphins is on the sides, herding the school inward, compressing the thousands of fish into a tighter and tighter ball. This formation is called a bait ball, and it doesn't happen by accident. Dolphins create bait balls deliberately, through coordinated movement. When the ball is tight enough, when the sardines are packed so densely they can barely move, the dolphins take turns diving through it, one after another. Each dolphin gets a turn. Each one eats what it can, and then it returns to the circle to keep the ball intact while another dolphin takes its turn. Read that again, because this is the part most people miss. The dolphins take turns. They don't all dive in at once and grab as much as they can. They cooperate. They share. They maintain the structure of the hunt while individuals feed one at a time. This is not animal behavior the way most people think of it. This is a team, a real team, with roles, with cooperation, with shared sacrifice for collective benefit. The dolphins have figured out something we humans took centuries to organize. That working together, even when it means waiting your turn, produces vastly better results than every individual fighting for themselves. Now I have to tell you about how dolphins actually perceive their world. Because once you understand this, you'll see why I keep saying their minds are like ours, but also alien. Dolphins have eyes, decent eyes. But underwater, vision only goes so far. So dolphins evolved something else. Something extraordinary. They evolved sonar. Not the metaphor of sonar, actual sonar. The same technology submarines use. The dolphin developed it about 50 million years before we did. Here's how it works. The dolphin generates a high-frequency click in its head, produced by passing air through specialized organs. That click projects out through the dolphin's forehead and into the water. When the click hits an object, a fish, a rock, another dolphin, a human, it bounces back as an echo. The dolphin catches that echo through its lower jaw, which conducts sound directly to its inner ear, and the dolphin's brain processes that returning echo into an image. Read that carefully. The dolphin doesn't just hear the echo, it builds a visual picture from sound. But it gets stranger. Dolphins can read echoes with such resolution that they can detect not just the shape of an object, but its internal structure. A dolphin scanning a fish can tell whether that fish has a swim bladder, how big its swim bladder is, whether it's pregnant, whether it's diseased, whether its bones are dense or hollow. Dolphins are walking around the ocean with built-in ultrasound machines. Imagine if you could look at a person and immediately see their skeleton, their organs, whether they have a tumor, whether they're pregnant, whether their heart is healthy. That's what the dolphin perceives every time it scans another creature. When that dolphin looked into your eyes during your beach vacation, it was also seeing your skeleton, your heartbeat, the internal anatomy of your chest cavity. The dolphin's view of the world is more intimate than ours could ever be. But here's where things get really beautiful. Because dolphins don't just use sonar to hunt. They use it to talk. Different dolphin pods have different vocalizations, different dialects of clicks, whistles, and pulsed sounds. Calves learn these dialects from their mothers and pod members, growing up speaking the family language. But each individual dolphin also develops something even more remarkable. Every dolphin has a signature whistle, a unique sound pattern that functions exactly like a name. When a dolphin is born, in the first few months of life, it develops a signature whistle that is uniquely its own. Other dolphins recognize this whistle and use it specifically when calling that individual. Dolphins call each other by name. That's not a metaphor. That's not an interpretation. That's documented, peer-reviewed, scientifically established fact. Dolphins have names. They give each other names. They remember each other's names, sometimes for decades. There are documented cases of dolphins recognizing the signature whistles of relatives they hadn't seen in 20 years. The dolphin equivalent of running into your cousin at a wedding after 2 decades and immediately remembering them. Names, recognition, long-term memory of individual relationships. This is not the cognitive life of a fish. This is the cognitive life of something far closer to us than we usually admit. I want to share something with you that, when I first learned about it, I had to read 3 times. In 2007, marine biologists in Australia documented a pod of bottlenose dolphins doing something nobody had seen before. The dolphins were using tools. Female dolphins in this pod had figured out that if they broke off a piece of sea sponge from the ocean floor and placed it over their snout, they could probe abrasive sand and rocks without injuring their faces. This allowed them to flush out hidden fish that other dolphins couldn't reach. This is tool use. Real tool use. Identical in concept to humans using a glove to handle hot pans. But here's the deeper part. This sponge tool behavior is only practiced by certain females in that one pod. Mothers teach it to their daughters. Aunts teach it to their nieces. The technique has been passed down through generations of female dolphins for at least centuries. Males don't do it. Other pods don't do it. It's specific to this matrilineal line. In any other context, scientists would call this what it is, a tradition. A culturally transmitted skill, taught from mother to daughter, surviving across generations, unique to one family. Dolphins have family traditions, just like humans. We share family recipes, family rituals, family knowledge. The dolphins share family hunting techniques. There is something so deeply moving about that to me. The idea that somewhere off the coast of Australia right now, a young female dolphin is being taught how to use a sponge by her mother, exactly the way her mother was taught by her grandmother, going back generations into deep time. Now I want to tell you something that genuinely changes how I think about dolphin intelligence. Dolphins pass the mirror test. This is a standard psychology experiment. You put a mark on an animal, a colored dot on its skin, for example, and then place that animal in front of a mirror. If the animal recognizes that the reflection is itself, it will try to look at the mark on its own body using the mirror. This test was designed to measure self-awareness, the understanding that I exist as a separate being in the world and that reflection is me. Most animals fail. Cats fail. Dogs fail. Most fish fail. Most birds fail. You know who passes? Humans pass, after about 18 months old. Great apes pass. Elephants pass. Magpies pass. And dolphins pass. Easily. Definitively. Dolphins understand that they exist as individuals. They know who they are. They have a concept of self. This is one of the most profound psychological capacities in the animal kingdom, and the dolphin has it. Combined with everything else, names, family traditions, cooperative hunting, language, tool use, decades-long relationships, and we're not really talking about animals anymore. We're talking about people, in a different body, in a different world, speaking a different language, with a different history, but people nonetheless. And now I have to share the part that hurts the most. We have not been kind to dolphins. Tens of thousands of dolphins are killed every year in fishing nets, caught accidentally and drowned. Many more die from ocean pollution, ship strikes, sonar interference from military activity, and the slow accumulation of toxins in their tissues. In some parts of the world, dolphins are still hunted directly, speared, slaughtered. Their meat is sold despite containing dangerous levels of mercury. In captivity, dolphins live shorter lives, suffer chronic stress, and show signs of severe psychological trauma. They are forced to perform tricks for tourists in tanks barely larger than a few of their body lengths. Tanks that, given their sonar-based perception, must feel like living in a tiny echoing room with no escape for their entire lives. We have known for decades that dolphins are extraordinarily intelligent. We have known that they have names, that they have cultures, that they recognize themselves in mirrors, that they form long-term bonds with each other. We've known, and we've kept hurting them anyway. That's hard to sit with. Because I started this video by saying these are minds that shouldn't exist. And in a way, that's true. The intelligence in our oceans is beyond what anyone would have predicted 100 years ago, beyond what most people walking around today even realize. But they do exist. They've always existed. We're just slowly waking up to it. So let me close this video with what I really want to leave you with. This entire documentary has been about one thing. Not survival, not adaptation, not biology. It's been about minds. The realization that the ocean is not empty. It's not silent. It's not just water and fish and currents. It's a living network of intelligences. Different from ours, alien to ours, but intelligence nonetheless. There are creatures down there that can solve puzzles in seconds, communicate in light, invisible to us, see structure inside other animals using sound, recognize themselves in mirrors, call each other by name, pass down traditions across generations, mourn their dead, form lifelong partnerships, hunt together as coordinated teams, and we, collectively, as a species, barely notice. We treat the ocean like a resource, like a setting, like background scenery for our beach vacations. But it isn't background. It's full of minds we don't understand, full of awareness we can't measure, full of relationships we're only beginning to map. Right now, somewhere off the coast of a country you may never visit, a pod of dolphins is moving through the deep. They are talking to each other, calling each other by name, coordinating their movements with sound that paints the water in textures we cannot perceive. The young ones are practicing the techniques their mothers are teaching them. The old ones are remembering things from decades ago. All of them, together, navigating the world the only way they've ever known how, socially. They are not alone out there. The octopus is opening jars in the dark. The cuttlefish is thinking out loud across its skin. The mantis shrimp is seeing colors we cannot imagine. The orca grandmother is leading her family through ancient migration routes. The great white is feeling heartbeats through kilometers of water. The seahorse is dancing with its mate at sunrise. The Moray is breathing slowly in its hidden hole, and the dolphins are calling each other by name. All of them alive, right now, as you watch this. The deep mind is not one mind. It is many, millions of them, spread across every ocean, every reef, every dark trench we haven't even explored yet. And maybe the most important thing this video can leave you with is this: we are not the only ones thinking on this planet. We never have been. The minds below the waves have been here longer than us. They will be here, hopefully, long after we're gone.
if we let them. So, the next time you see the ocean, whether it's in real life or just on a screen like this one, try to see it differently. Not as water, as a city. A vast, deep, ancient city full of citizens we barely understand. And quietly, gently, try to be a better neighbor. That's all the ocean is asking from us. To remember that we share this planet with minds, and to act like it. If you made it through this entire video, genuinely thank you. 2 hours is a lot of your time, and the fact that you stayed to the end tells me you care about these animals as much as I do. That means more to me than you know. If you enjoyed this, like the video. Subscribe to Marine Planet. There's a lot more coming. And if you want to help me keep making documentaries like this one, you can buy me a coffee. The link is in the description. Every coffee directly funds the next video. I'm curious about one final thing before you go. Which mind in this documentary affected you the most? Tell me in the comments. I read them all. Until next time, take care of yourselves. And take care of the ocean. I'll see you in the next one. Marine Planet.